Alright, here we go. Last video. I know you're disappointed. So, we're going to do some gas law stoichiometry. So, we're going to put together gas laws and stoichiometry and see how they work. Like any good stoichiometry problem, we need a chemical equation, and I've already balanced it for you here. So, hydrogen sulfide reacts with sulfur, alright, dioxide, to give us water and solid sulfur. The question that goes along with it is, if 6.00 liters of this lovely hydrogen sulfide gas at 750 torr produce 3.2 grams of sulfur, calculate the temperature in degrees Celsius. Alright, so we want to figure out the temperature in degrees Celsius. We kind of look at some of the information we're given. We're given a volume here of 6.0 liters, and this goes with H2S, so it's with hydrogen sulfide. Alright, they give us a pressure of the hydrogen sulfide of 750 torr. Alright, then this grams doesn't go with this hydrogen sulfide. This is grams of sulfur. Alright, if eventually we're going to use the equation PV equals nRT, we also know what R is. R is 0.0821 liters atmospheres per mole Kelvin. So we know what R is as well. Well, what are we missing here? We're missing, the N, the number of moles of H2S, and we're missing the temperature, which is what the question asks, what the temperature is. So there's two variables we're missing here. So we must have to be able to get one of them. Now, we're going to eventually have to calculate temperature with this equation. So we must know or be able to find out the N here, the number of moles. Well, how do we get that? We're going to use this value here, the 3.2 grams of sulfur. Because I'm given a balanced equation, if I know how many grams of sulfur I make, can I convert this to moles of H2S? Hopefully your answer is yes, you can. In stoichiometry we did that. So let's go down here. We're given 3.2 grams of sulfur. Okay, I want to cancel out grams of sulfur, and I can go to moles of sulfur. And then, from moles of sulfur, we can then go to moles of H2S. Alright? So we have grams and moles together. What we want to do, make sure we have a lovely periodic table with us in the calculator. Alright, so grams and moles together. Mole here is 1. Mass from the periodic table of sulfur is 32.07. Over here, mole and mole together. Hopefully remember mole and mole together. When you do this, you look at the coefficients in the balanced equation. Coefficient for H2S is 2. Coefficient for sulfur is 3. So go down here, this coefficient was 2. This coefficient is 3. Once again, these numbers, mole over mole, the numbers come from the coefficients. Alright, so we plug this in to our beautiful calculator here. And I got 3.2 divided by 32.07 times 2 divided by 3. I only have 2 sig figs on this one, so I get 0.067 moles of H2S. Alright, now I have the N, the number of moles. So I have all of these I can solve for T. Before you do though, you gotta be careful. This pressure is in torr, and the R that we're using is in atmospheres. So we need to convert that as well. So 750 torr. Now your conversions are on the pressure sheet, the first one that's in your packet. There's 760 torr for every 1 atmosphere. So we'll plug that in. Keeping only 2 sig figs, I get 0.99 ATMs. And now we can plug in. I'm going to rewrite our equation down here so you can see it. PV equals nRT. Our pressure, 0.99 atmospheres. Times our volume. Our volume given is 6.0 liters. Is equal to N. All right, N is 0.067 moles times R. R is that constant I'll always give you. 821 liters, atmospheres per mole Kelvin times, well, we don't know what T is, that's what we have to find. Alright, so if I want to get T by itself, I'm going to divide all this over here. So rewrite this 0.99 ATMs times 6.0 liters divided by 0.067 moles times 0.0821 liters atmospheres per mole Kelvin is equal to T. Alright, when I divide these, this atmospheres and this atmospheres cancels. That liter and that liter cancels. Moles and moles cancel. We're going to be left with Kelvin. So let's put this in our calculator. 0.99 times, that's 6.0. Divided by, now if I'm going to put this in my calculator together, you probably want to put parentheses. Divided by 0.067 times 0.0821, close parentheses, equals, my temperature is equal to 1,000, and we only have 2 sig figs here, so that'd be 11,000 actually, Kelvin. Now, you gotta be careful here. It says, what's the temperature in Celsius? That should be a degree sign there, I apologize. What's the temperature in Celsius? Well, right now it's in Kelvin, so how do you go to Celsius? Well, you're going to take it the opposite way. Instead of adding 273, we'll subtract 273 Kelvin. And 1100 divided, minus 273 Kelvin. The calculator tells you it's 827 Kelvin. For purpose of right now, that's fine. However, when subtracting, you look at places. So the real correct answer with this in sig figs is temperature is equal to 800. Oops, I put Kelvin there. That is incorrect. Apologize. That should say degrees Celsius. This is 800 degrees Celsius. If you got to 827 temperature in degrees Celsius, all right, so you get 827. I'm fine with that. I just want you to get this. This is a little difficult. Take some time to get. So if you get this, either one, I'll be happy with it. Okay, and that's gas laws and stoichiometry.